Hi everyone, in this video I'm going to differentiate questions A and B, and I will do the rest of them in the next video. So this exercise, which is 9E, is all about using the quotient rule to differentiate different functions. But remember that in probably most of them you need to use some other differentiation techniques that you have learned in the previous chapters. So in case you feel you are not confident with them, you can go back and watch the videos on those, for example, chain rule or some standard differentiations or trigonometric differentiations and so on. So for the first one, is indeed the type that we need to be comfortable with some of the more standard differentiations, because we have both cosine and also exponential function. So as I mentioned in the previous video, if you want to differentiate using the quotient rule, it's always that you first you can use the formula of the quotient rule. For example, it's up to you, because if you have two functions, just to quickly remind you the quotient rule. So let's say your first function is u of x, and also you have another function v of x. So if you want to write them properly, the format of the quotient rule is something like this. So u of x on top, and then you have v of x in the denominator. So how do you use the quotient rule? So basically it's dy dx is equal to basically the denominator function squared. Then for the numerator, you start with writing the denominator function times the derivative of the numerator function minus, now you reverse the roles. So for example, this time you start with the numerator function u of x times the derivative of the denominator function. So this is the quotient rule. You can just memorize in words that you start with the denominator function times the numerator function differentiated, then minus the numerator function times the denominator function differentiated, or just remember the formula each time and use the formula. Now going back to the question, so let's start by the simplest step, which is just basically squaring the denominator function, because in the denominator that's very simple. You just square the function that is in the denominator. Now for the numerator, we start with writing the function on the denominator times the derivative of the function on top. So remember that basically u in this case is e to the 4x, and the derivative of u is 4e to the 4x. It's just exponential function. So that we are going to have cos x times 4e to the power of 4x minus, now you write the function of u, which is e to the 4x, times the derivative of the denominator function. So the denominator function is simply cos x, and cos always differentiates to minus sine x. So you have minus sine x. So it's multiplication. And yeah, you can simplify this. It's up to you, but I will just leave my answer in this form, because normally in quotient rule questions you are going to get some very messy fractions, and most of the times they don't ask for a simplified answer, so you can just save a bit of time and just move on. Okay, part B. We have y is equal to ln x divided by x plus 1. So dy dx is equal to the denominator squared, simply x plus 1 squared, then the denominator function, which is x plus 1, times the derivative of the numerator function. So remember that ln x always differentiates to 1 over x. So I have an entire video about these log differentiations. Then we do minus, then the numerator function, which is ln x, times the derivative of the denominator function. So the denominator function, just because it's x plus 1, it just differentiates to 1. It's very simple. And yeah, so this is basically what you're going to get. Again, if you like, you can simplify, but I'm just going to leave the answer in this form. So that's it for this video. In the next video, I'm going to continue with the rest of the exercises. And yeah, so thank you for watching.